Physics is easy. There is no reason to get scared of physics. The most exciting news is that physics is already made in nature around you, and also the everyday things you use are made from physics theory. If you stop physics for one day, you can't use no microwave, no phone. No phone means no social media. No YouTube or Instagram phone is run by literally quantum mechanics of physics. What about car, which is literally run by Newton's law of motion? No frequency or wave, no TV or phone which carry sound waves so we can call others and hear their voices. What about amusement parks? No roller coaster or fun rides, which is all about kinetic and potential energy. In nature, everything will be displaced and chaotic without physics theory. No gravity, everyone will start flying. No day and night, it will be forever day or forever night. Can you take it? No way. No blue sky as blue light scattered more than any other colors. We might have to deal with a black sky. Scary, right? No physics theory means no friction, no need to press on the gas to ride cars. Cars would be moving on roads crazily, just like when there's snow. If you just Google or try to find out why the world is as it is, it's physics that the Creator already set for us. There wouldn't be any X-rays or CT scans or so many other medical exams possible without physics theory. No medical checks mean doctors can't find diseases. Can we take it? No way. Physics in sports. Physics plays a crucial role in sports. From the trajectory of a basketball to the spin of a soccer ball, understanding the principles of physics can enhance performance and strategy. Let's explore how athletes use physics to their advantage. When a basketball player makes a perfect shot, they are using the principles of projectile motion. The angle, speed, and spin of the ball are all calculated, even if subconsciously, to ensure it goes through the hoop. Similarly, a soccer player uses the Magnus effect to curve the ball around the wall of defenders. The spin they impart on the ball changes the air pressure around it, making it swerve mid-air. In baseball, pitchers use aerodynamics to throw curveballs and sliders, making it difficult for batters to predict the ball's path. Even in swimming, athletes use the principles of fluid dynamics to reduce drag and increase their speed in the water. Understanding these principles not only helps athletes perform better, but also allows coaches to develop more effective training programs. By analyzing the physics behind each movement, they can fine-tune techniques to maximize efficiency and minimize the risk of injury. Physics isn't just a subject in textbooks, it's a vital part of the sports we love. So next time you watch your favorite game, remember, there's a whole lot of science happening right before your eyes. Physics in space. Space exploration relies heavily on physics. From launching rockets to navigating spacecraft, the laws of physics are fundamental. Discover how physics helps us explore the final frontier. When rockets launch, they must overcome Earth's gravity. This requires an understanding of Newton's laws of motion. Engineers calculate the exact amount of thrust needed to propel the rocket into space. Once in orbit, spacecraft navigate using principles of orbital mechanics. This involves precise calculations of speed, trajectory, and gravitational forces. The International Space Station, orbiting Earth at over 17,000 miles per hour, relies on physics to maintain its orbit and provide a livable environment for astronauts. Inside, microgravity allows scientists to conduct experiments that are impossible on Earth, furthering our understanding of physics and its applications. Even the communication between Earth and distant spacecraft relies on the physics of electromagnetic waves. Signals travel vast distances at the speed of light, demonstrating the principles of wave propagation and the Doppler effect. Understanding physics not only makes space exploration possible, but also helps us answer fundamental questions about the universe. From the behavior of black holes to the expansion of the cosmos, physics provides the tools we need to explore and understand the final frontier. As we continue to push the boundaries of space exploration, physics will remain our guiding star, illuminating the path to new discoveries and adventures. Physics in music. The sound waves that create music are a fascinating application of physics. Learn how different instruments produce sound and how acoustics shape the music we love. Every musical note we hear is the result of vibrations traveling through the air as sound waves. When a musician plays an instrument, they are setting off a series of physical events that produce these waves. For instance, when a guitar string is plucked, it vibrates at a certain frequency, creating sound waves that our ears interpret as musical notes. Wind instruments like flutes and trumpets produce sound through the vibration of air columns. By changing the length of the air column, musicians can alter the pitch of the notes they play. Percussion instruments, such as drums and xylophones, generate sound through the vibration of their surfaces. The size, shape, and material of these surfaces affect the sound's pitch and timbre. Acoustics, the branch of physics concerned with the properties of sound, plays a crucial role in how we experience music. The design of concert halls and recording studios aims to enhance sound quality by controlling how sound waves reflect and absorb within the space. Understanding the physics of sound waves and acoustics allows us to appreciate the intricate science behind the music we enjoy. From the resonance of a violin to the echo in a cathedral, physics enriches our auditory experience, making music a profound and universal language. Physics in medicine. Medical technology, from X-rays to MRI machines, is grounded in physics. Explore how these technologies work and their impact on healthcare. X-rays, discovered by Wilhelm Conrad Röntgen in 1895, revolutionized medical diagnostics. By passing a controlled amount of X-ray radiation through the body, we can create images of bones and tissues, helping doctors diagnose fractures, infections, and tumors. Magnetic resonance imaging, or MRI, leverages the principles of nuclear magnetic resonance. When placed in a magnetic field, the nuclei of certain atoms in the body resonate at specific frequencies. By detecting these signals, MRI machines can produce detailed images of soft tissues, providing crucial information for diagnosing conditions like brain tumors and spinal cord injuries. Ultrasound technology, another marvel of physics, uses high-frequency sound waves to create images of internal organs. It's widely used in prenatal care to monitor the health of developing fetuses, as well as in diagnosing conditions in organs such as the heart and liver. Radiation therapy, which employs high-energy radiation to kill cancer cells, is another application of physics in medicine. By carefully targeting tumors with precise doses of radiation, doctors can treat cancer while minimizing damage to surrounding healthy tissues. The physics behind these technologies not only aids in diagnosis, but also in treatment, improving patient outcomes and saving lives. Understanding the principles of physics allows medical professionals to innovate and refine these tools, pushing the boundaries of what's possible in healthcare. From the clarity of an X-ray image to the life-saving precision of radiation therapy, physics is at the heart of modern medicine, enhancing our ability to diagnose, treat, and ultimately heal. Physics in nature. Nature is a playground of physics. From the flight of birds to the flow of rivers, physics explains the natural phenomena we observe every day. Let's delve into the physics of the natural world. Consider the flight of birds. The principles of aerodynamics, such as lift, thrust, drag, and gravity, enable birds to soar gracefully through the air. Their wings are designed to manipulate air pressure, creating lift that allows them to stay aloft. Observing a bird in flight is like witnessing a living demonstration of the laws of physics. Next, let's look at rivers and streams. The flow of water is governed by fluid dynamics. The speed and direction of a river's current are influenced by factors such as gravity, the riverbed's shape, and obstacles in the water's path. These principles not only explain the meandering paths of rivers, but also guide engineers in designing efficient water systems. The majestic phenomenon of a rainbow is another example. When sunlight passes through raindrops, it refracts or bends and then reflects off the inside surface of the drop. This process splits the light into its constituent colors, creating a beautiful spectrum in the sky. Physics allows us to understand and predict this enchanting display. In the case of lightning, the principles of electricity and magnetism come into play. During a thunderstorm, the buildup of electrical charge in clouds creates a powerful electric field. When this field becomes strong enough, it discharges rapidly to the ground or to another cloud, producing a bright flash of lightning and the accompanying thunderclap. Even the gentle fall of a leaf is a study in physics. The interplay of gravity, air resistance, and the leaf's shape determines its descent. Each flutter and drift is a dance choreographed by the laws of physics. By observing these natural phenomena, we gain a deeper appreciation for the intricate workings of the natural world. Understanding the physics behind them not only satisfies our curiosity, but also inspires us to explore and protect the environment around us. Nature, with its endless wonders, is a testament to the beauty and power of physics. As we continue to study and explore, we uncover the secrets that make our world so extraordinary. No amusement park roller coaster rides, no swings, or no Universal Studios Harry Potter attractions. Physics theory is already made. All we need to do is observe, think, and find out what's the reason behind it. The reason is the physics theory. Once you understand it, you will be so amazed, and you will think, why was I so scared of physics? It's like a magic world. Once you discover it, everything makes sense. This is why you will see people who are good at physics are very confident. We all can do it. Let's explore together. Share this video with your friends and family and subscribe for more exciting content.